Hi, my name is Greg LeBlanc here at the Haas School. My guest today is Matt Shumpert, who is Director of Product Management at Datameer. Welcome, Matt. So Matt, one of the things you were talking about is data science without the data scientist. Maybe you can tell me a little more about that.
Yeah, sure. One of the things I've observed over the last 5 years in working in the big data space is that there's this incredible sort of unmet demand for data scientists, and it requires a skill set that's really hard to come by, really hard to retain, with as hot as the job market is in high tech and big data in particular. So there need to be better tools to sort of lower the barrier to entry into data science. Some of the things that data scientists do today are very, very advanced. Some of them are actually more routine, and we shouldn't have to have a PhD or master's in computer science to be able to accomplish those tasks.
Yeah, and so how are those? How is that being? How is that need being met?
Well, really tools. So really, I work in the enterprise software space, business software, and the tools really are being built up on this foundation of big data infrastructure technology. So there's been a shift from traditional database and data warehouse technology to new big data platforms like Hadoop. There's other databases like MongoDB, Cassandra. These are the NoSQL databases, the newer variety. And on top of those, there's not as rich of a tool ecosystem of applications and tools for various roles: developers, data scientists, and business analysts. So we work in the business analyst domain, and again, enabling people without those more technical skills to get at the data, ask a question as routinely as they would in Excel or their favorite business intelligence platform.
So how important then is the user interface or the user experience? I mean, it seems like you've got people that come in, they all know how to use Excel, they all understand the interface, it's relatively simple, and I think what you're suggesting is that you can take an interface like that and put it on top of something that is much more sophisticated.
Right. The trick is sort of to convince people that they're doing something they did before and that they know how to drive the car effectively. So the analogy you were using earlier about making it look like a car, but actually you're driving a spaceship is kind of the approach that we took. And the car is Excel. Everyone knows how to use Excel. There's about 800 million users of Excel worldwide, by far more than any other business intelligence tool on the planet. And so there's a skills base there. There's a comfort level. There's an approachability that people have when they work with a familiar tool. So that's really important. And then when we're dealing with these very large and sometimes unstructured data sets, data visualization tools are very important, because you can't just throw all the data against a wall and make sense of it in its raw form. You have to refine it through a number of stages in order to make it relevant. So you have to use some machine learning or other computational techniques to extract the signal from the noise, if you will, and then be able to visualize it in a way that's intuitive for people. So new types of visualizations for the textual data, the unstructured data, and just new ways of aggregating or distilling large data into a visual that makes sense.
Now, we all know that everything's changing really quickly in this space. And some of the things that were not commodified are now becoming commodified. Could you speak to a little bit about how that is playing out?
Yeah, so the traditional data analytics architecture, if you will, for companies was they would buy several pieces of expensive enterprise software and stitch them all together. And sometimes they'd be from different vendors, and they would use commercial software, commercial hardware, proprietary environments, very closed systems, top to bottom. The appliance was a very popular kind of form factor where you'd roll in the refrigerator and it would have everything soup to nuts in it. And that's being kind of broken down into these multiple layers, and each of those layers is getting cheaper and cheaper, and different participants in the market can come in and make those layers better and cheaper. So in the context of the area that I work, which is Hadoop, you've got commodity hardware, so cheap servers using the same kind of processors you have in your smartphone or your laptop, driving down the cost of the hardware for companies, because they'll use that and they'll replace frequently that hardware because they're not locked in. And then on the infrastructure software, or what we used to call the middleware layer, there's massive investments right now in new technologies like Hadoop and providers of that technology who maybe take something from open source, make it a little bit better, package it up, ship it, and offer support and services around that. So it's still a much lower cost model, even though you're paying something to use the technology. So all these layers are getting cheaper and cheaper. And as an extreme example, I talked to one bank a few years ago who was using one of the old technologies, the data warehouse technologies, and they were paying, I think in 2010, almost $500,000 a terabyte. and you get on to Best Buy and you buy a terabyte hard drive for $100, you know it shouldn't be that expensive, right? Even with some software and services around it, you know, we're down to sub $1,000 per terabyte unit cost for a platform like Hadoop for a company to operate, even with power and cooling and all the rest in their data center. So that's a huge gulf between where the price point was then and where it is now. And the companies that were selling at that price are obviously having a harder time.
So by moving back more towards a modular system, it allows the development cycles to be to move independently of one another.
Exactly, they're decoupled, right? Hardware, software, and then analytics applications on top, like us. And they're also the pace of innovation is faster because of open source. Because everyone who's playing in that pie, if you will, or in that stack, can consume open source technology and get to their final goal faster. And so, businesses have also learned to accept the validity of open source model. They can trust running open source software in production, especially if they've got a vendor to go and call when something goes wrong.
Well, Matt, thanks for coming in today.
Thank you, Greg.